All right, students, so at this point you should have watched our part 1 already that led up to this slide, slide 16 that says parts of an experiment. If you have not watched that part, please go ahead and do that ahead of time. This will be for the back side of that note sheet for the parts of an experiment in those experimental groups. So I'm going to go ahead and click and begin here. All right, so let's talk about the parts of an experiment. In class, we'll be doing a lot of that experimentation. And what I want to do is make sure that we really understand when we're doing an experiment, what are those parts that we have to have? Because without these certain little stepping stones, we can't have a successful experiment. And we're not going to be able to understand what's going on and to collect that very important evidence. So each experiment will have variables. Hopefully you've heard of this term before. But there are 3 variables. The first one is called the independent variable. All right, the independent variable. And this is what's different between these 2 groups that we're going to discuss later on that we're going to have, those groups being a test and control group. But to help us understand independent variable, I always ask myself the question, what are you testing? So if you're trying to determine what the independent variable is, ask yourself the question, what are you testing, right? What you are testing. The second example, or the second variable that we have here, is the dependent variable. So it's different from the first, being that it's dependent and not independent. What is this variable? Well, simply it's asking yourself the question, what are you measuring, right? It is what you are measuring, okay? And I will give examples with these variables in a situation here in a moment, but for right now, I just want us to understand what these definitions mean with these different variables. So the last one is the controlled variable. And this one I really like because it says it in the name. It's what you're controlling, okay? These are the things you're going to keep the same to make sure your test is fair. All right, so what are you controlling? What are you keeping the same? And like I said, I usually ask myself those 3 questions. And that helps me determine what these variables are, which things are these variables. So what are you testing? What are you measuring? And what are you keeping the same? Right? I ask those 3 questions to help me understand what these 3 variables are in my experiment. So let's go ahead and practice this with the situation. All right, so here's our example. Doctors are studying a weight loss drug, and volunteers for the study are going to be recruited. All the volunteers in this study are in their 30s and at least 50 pounds overweight. Now, in this example, we need to find those 3 variables. Okay, so let's ask ourselves the first question. What are we testing? Well, in this example, what is being tested? And what I love is that it usually says it right away in that first sentence. It says they are testing or they are studying or they are experimenting. Well, in this situation, doctors are studying what? A weight loss drug. So this answer is weight loss drug. Our independent variable, what is being tested, is the weight loss drug. So let's try this again. Let's ask ourselves the second question. What are we measuring? Right? What are we measuring? Well, the independent variable gets you a hint. If we're testing the weight loss drug, what can we measure about this to collect data? Right? Because remember, our experimental goals is we need to collect some sort of evidence, right? And evidence is that data, okay? So in this example, what is being measured? Well, with weight loss drug, we're going to measure how much weight they lose. All right, do you see that correlation? How if we're testing the weight loss drug to determine if our experiment successful or not, we have to collect some sort of piece of evidence, and that's going to be the amount of weight loss. Now, pause here. Question. Is this evidence, the amount of weight loss, is that going to be a quantitative piece of evidence or a qualitative piece of evidence? Think about amount of weight loss. It's an amount. It's going to be quantitative because remember that is a quantity and not a description. All right, so third variable, let's think here. What are we controlling in this experiment? What are we keeping the same? And what I always think helps me out is that the word all is very important here because it says all means that everybody has to have these things. All people have to have these, and that is being in their 30s and 50 pounds overweight. So that's what we're controlling. We're saying everybody in this study, the people that we recruited, have to be in their 30s and 50 pounds overweight. All right, we need to talk about these 2 different groups and then we'll be almost finished here. So in our experiment, not only do we have to have 3 variables, but there are always 2 different groups. One of them is called the test group, or you might hear it called the experimental group. And this group is going to get our independent variable. So in our previous example, that would have been the weight loss drug. They are going to get whatever we're testing. The other group is the control group. And it's going to be very similar to our controlled variable in that we're going to make sure some things don't happen, or we're going to control some things with them. For instance, in the control group, we're going to make sure they don't get the independent variable. We're going to keep them from receiving treatment from the independent variable, okay? And we might refer to this group as the normal group, all right? So you might hear it referred to as the normal group. And the reason we have a control group is we want to compare our results in the end. We have to compare whatever we're testing to something normal or to something different to see what is the difference, right? When we make comparisons, we can't compare one thing. We have to compare one thing to another, right? We have to compare apples to oranges. We have to compare my yard to the neighbor's yard, right? So in this example, we have to compare our experimental group to our control group. In our previous example, we talked about the doctor studying the weight loss drug. So our experimental group, keep in mind, is the one that receives treatment. It's the one that gets the independent variable. So in this example, our independent variable was weight loss drug. So our experimental group is going to be a group of people that takes the weight loss drug or takes that pill. And remember, our control group is the one that is the most normal. So our control group, they're not going to get that treatment. They're not going to get weight loss drug. And I don't want this to be confusing here. So if we read the sentence, it says they take a placebo or sugar pill. And let me explain that. A sugar or placebo pill, should it cause weight loss? No, it should not. So when you're thinking about the control group, oftentimes in medical studies, the control group will still receive a pill, but the pill will do nothing. All right. In our studies, most often we'll just remove the independent variable so they don't have it. So for instance, if we're doing a study on plant growth and we want to see if the amount of sunlight changes the height of a plant, our independent variable is we're testing the sunlight and we're measuring if it changes the height of the plant. So our control group will be it gets normal amount of sunlight, right? We just keep it outside. All right. But in this experiment, we can either have them take a sugar pill, or we can say they won't take a pill at all, right? And nothing should happen there. All right, the very last thing we have to do in our experiment is, now that we're finished and we've collected our evidence, we now need to make a conclusion. To make a conclusion, we have to look at our evidence and data. We have to use the information we collect to come to that conclusion. And we can't use what we think, right? Remember, when we talk about observations, we can't have our biases get in the way. We can't have what we think should happen, what we think we want to be the answer, or what we want to actually be the answer get in the way. We can only use our information that we've collected. So from our example, let's say the experimental group, remember the one that got the weight loss drug, lost 15 pounds in a month. And let's say our control group, remember the group that did not get that pill or got that sugar pill, let's say they only lost 5 pounds in a month. From the data that we collected, right, the evidence that we collected, notice this is quantitative evidence in the form of numbers here, what would we conclude? Well, looking at our numbers, 15 is larger than 5. So we can make the conclusion that, did this weight loss pill work? Yes, it did. Because if someone took it versus taking nothing, they lost more weight. So our conclusion is the weight loss drug increases the amount of weight lost in a month, right? And we're very explicit in stating that the pill increased this. We can't say the pill is better, right? Even though it is, because notice that sounds biased. We have to say this caused this, caused this. We have to be very analytical is what you might call it, very evidence-based. The weight loss drug increased the amount of weight loss because, again, that is what occurred. All right, so that is we are finished now with our slides. What you can do is please make sure that your notes are filled in adequately, and please go on to the next step in our Google HyperDoc. Thank you for listening.